So, ready? Psst. Yeah, looking at you. First of all, some quick review. Remember, we said reference angles work as follows. If the angle is in quadrant 2, where is the reference angle? Right there. If the angle is in quadrant 1, yoink, where is the reference angle? Oh, change colors, Mr. Dueck. Right there. If the angle that we're dealing with is in quadrant 3, yoink, which is the reference angle? Right there. If we are in quadrant 4, which is the reference angle? Always the one to the closest x-axis. And that's why you see me going, it's this one or it's this one. Okay? Let's remember that. That's the first thing we're going to put in our back pocket and pull it out a bit later. Also remember the cast rule. So we said that the cast rule looks like this. And it tells you whether cosine or sine or tangent or all of them are positive and in which quadrants. Okay? Also remember the reciprocal trig functions behave just like their primary counterparts. So for example, if tangent is positive down here, so is cotangent. If cosine is positive down here, so is, which one goes, secant. If sine is positive up here, so is cosecant. Oh, and everything's positive in quadrant 1. And again, Jacob, the reason we never had to bring any of this in grade 11 or grade 10 or grade 9 is because you're dealing with triangles. You couldn't get an angle bigger than 90 degrees. It wasn't an issue. But now we're going around the circle. It is an issue. On your calculator, find the sine of 30.
Sine 30 equals
0.5. Now, here's what else that means, Jake, my friend. Supposing I could give you a trig equation. Now, what I mean by a trig equation is where I don't know the angle. If I said to you that the sine of a mystery angle equals 0.5, can you tell me what the mystery angle is? Well, from here, it's obvious because I just did the question. The sine of what was 0.5? 30. So if the sine of a mystery angle is 0.5, what's the mystery angle? How can I get my calculator to show me that? Well, first, I need to make sure I'm in degrees, and I don't think I am. 1. Yeah, I'm in radians. Degrees. Okay? To go backwards, to find an angle, we have to use the shift button. If right now you go shift sign and you know you've hit the shift button because a little -1 appears, that's the symbol for inverse or going backwards, do that on your calculator. Please go shift sign and you type 0.5 and hit enter. It should give you the angle back. Yes? Okay? So we can go forwards, we can go backwards. So, example, next page. Guys, with me? And it should work on yours too, Roseanne? Yeah, scientific one? It's going to be a shift or a second function or an inverse. I don't know what it's called. Okay. So, here's the questions we're going to be solving today. Find theta if cos theta equals 0.2588. Well, which trig function did they give me? Which trig function did they give me? Which trig function, folks, I need you here. Which trig function did they give me? Hello? Cos. So I want to find the angle. So I'm going to go second function or shift cos of 0.2588. What's theta? What angle did it come from? Trying this on your calculator? That's the whole point. What do you get? Yeah, 75. We've rounded off a bit, 75 degrees. So, to solve a trig equation, to find an angle if they give me the decimal portion, we use the shift or second function or inverse, whatever it's called. On the Casios, it's called shift, which is symbolized as or, That's how we can write shift sine, shift cos, shift tan. Okay? That's much shorter than writing the word shift in front of your work every time, so we'll use that. So, what is the tangent of 38 degrees? Can you find that on your calculator to 4 decimal places? Tangent of 38, you get 0.7813. Let's write that down here. What that means, Seb, is if I go shift tan of 0.7813, I should get 38 degrees. I should get the angle it came from. If I go shift tan of 0.7813, now I don't quite get 38 degrees. Why don't I get exactly 38 degrees? Because I rounded this off. But I do get 38 degrees, right? Check. Yeah. Find the sine of 68 degrees. Oh. 0.927, I don't think 1. 2, yes? Right? Rounding off properly? 0.9272. Folks, I need you to stop talking in the back corner. I'm going to move you. What that means then is this. If I go shift or inverse sine of 0.9272, I should get back 68 degrees, which I do. So far, so good. And my physics students are going, big deal. Find the sine of 138 degrees. You get 0.6691. So that means if I go shift sine of 0.6691, I should get back 138 degrees. That someone's phone on vibrate. I need you focused here. Can you try that, please? What? No, try that. What? This is the whole point of this lesson, and you're all zoning out. Try that. Does it work? No. If you go shift sine of 0.6691, do you get back 138 degrees? I say no. This is going to be our problem. What we want to do is we want to solve trig equations, but the problem is your calculators are incapable of solving them properly. They can't. We are going to have to use all of our skills that we brought to bear to solve these. Uh-oh. Find the cosine of 340 degrees. Go shift cos, and then of the answer button, go shift cos of 0.9397. Do you get 340 degrees back again? No. So it turns out the cosine of 340 degrees is 0.9397. The cosine of 20 degrees is also 0.9397. When you go shift cos, your calculator does not know which angle you came from. It doesn't know which angle you want. It doesn't know whether you want it to give you the 20 or the 340, because both are right. What's the tangent of 110? Tan of 110, negative 2.747. What's the tangent of 290? And in fact, if I go shift tan of negative 2.747, I don't get any of those. I get negative 70. The heck? And the answer is our calculators, all scientific calculators, the way the software is written, they don't solve trig equations very well unless they're between 0 and 90, which is why, again, in physics, we've never had to deal with this because all of our angles in physics are between 0 and 90. For every sine and cos and tan value, there are actually two possible angles that they could have come from if we stay between 0 and 360. In fact, there's an infinite number of angles, Connor, if we allow ourselves to keep going around and around and around, but we're going to stay between 0 and 360. How can we find both? We're going to have to do a procedure, and this is what's going to be on your test. This is how we're going to solve trig equations. Whenever I say solve a trig equation, you're going to be looking for two angles. For two angles. Turn the page. How do we solve trig equations? Step one, we're going to do a sketch and use the cast rule to figure out what quadrants these angles are in. Okay? Step two, what we can do is we can trick our calculators into always giving us the reference angle. And if we know the reference angle, we can figure out the full rotation angle. Show you what I mean. Example 1 says, solve sine theta is 0.5. Here's the first question I ask. Sine of the mystery angles, I'm looking for two of them, was my answer positive or negative? You're right, louder. So, you know what? Let's do a little sketch over here. Let's write in the cast rule. Where is sine positive? Which two quadrants? The two angles I'm looking for are here and here. Draw those in. That's step one. Okay? Oh, step two, find the reference angle. Now, how do I find the reference angle? My symbol for reference angle is capital R theta, reference R theta, my symbol for an angle. That's going to be the inverse sine of 0.5. Can you all do that on your calculator? The shift sign. Okay. What your calculator gives you is the reference angle. Now, where is the reference angle? The reference angle is that, and it's that. We're looking for two angles. I'm going to call them theta 1 and theta 2. How big is the first angle? That big. How big is that? 30 degrees. It happens to be the reference angle. Theta 2 is that big. How big is that? How can I figure it out? I'm going to have to do some arithmetic. It's 180, take away 30, because if I go all the way, that's 180, and we're 30 degrees less than that. I think this one you can do in your head. What is 180 minus 30? 150. Try it on your calculator. Go sine of 150, should be 0.5. Go sine of 30, should be 0.5. Try it really quickly. All of you. Sine of 150 equals sine of 30 equals. Right? So we're right. We can check our answer. We can check our answer. But you'll notice I had to add a little this thing. Why did I have to tell you that? Well, understand, you could have said that angle, which would be 150 plus 360. You could have said that angle, which would be 150 plus 360 plus 360. There's an infinite number of possible answers. So I'm always going to add a domain restriction. What I'm saying, Rachel, is just find once around the circle and quit. You don't need to keep going. This is me being fussy, but true. Okay? So why did I have to add between 0 and 360? We only want once around the circle. In other words, if I go 360 plus 150, the sine of 510 is also 0.5. Yeah, I don't care about that. I just want, get me the two principal positive angles between 0 and 360. Okay? So what did we say our strategy was? Step 1, use the cast rule to find the quadrants. Step 2, find the reference angle. And then step 3, using your sketch, find the rotation angles. Next one says solve tangent of theta equals negative 1.54. Which trig function did they give me? Let's do a sketch over here. Let's write the cast rule. Now, according to this question, was tangent negative or positive?
Negative.
Where is tangent negative? Must be there and there, because it's positive in the other ones, right? Don't just go looking for a t tangent. This cast rule tells you where they are positive. So step 1, I can tell you what quadrants they're in. You okay with that, Jake? What is step 2?
Find the reference angle.
Now, using the shift button, and then I put something in bold font. What did I say?
We always enter the positive value of the ratio in our calculator.
So I'm going to go like this. To find the reference angle, I'm going to go shift tan, not of negative 1.4. Not of negative 1.4. I used the negative to figure out where I am on my circle. I'm going to go shift tan of positive 1.4. .54. I think I said 1.4. 1.54. 57 degrees. That's the reference angle. What that means is that this angle right here is 57 degrees, and it means that this angle right here is 57 degrees. I want to find theta 1. I want to find theta 2. Theta 1 is that angle. How can I figure out how big that angle is? 180 minus 57, which is what? Which is what? 123? Yeah? The second angle is that one. How can I figure out how big that one is? 360 minus 57. 303. Quick double check right now. Find the tangent of 123. It should be really close to negative 1.54. Find the tangent on your calculator of 303. It should be really close to negative 1.54. I'm showing you, by the way, how you can check your answers on your test. Right? Yes? We're good? Sure. Okay. Solve cosine of theta is negative 0.5. Which trig function did they give me? We're going to do a sketch over here. Write out the cast rule. So the trig function they gave me was cosine. Was cosine, according to this question, was my answer negative or positive? Negative. Where is cosine negative? 2, I agree. Not 4. A is all. Here and here, look up. Right? 2 and 3. All are positive, sine is positive, tan is positive, cos is positive, so they're negative in the other locations. Find the reference angle. The reference angle is going to be the shift cos, not of negative 0.5. I used the negative to figure out where I am on the circle, of just plain old 0.5. What's the reference angle? 60? Yeah? What that means, my friends, is that that angle is 60 degrees. and that angle is 60 degrees. This is what your calculators can give you. Theta 1 is that guy. How can I figure out how big that guy is? Christina, you're right. 120. Theta 2 is, that guy. How can I figure out how big that guy is? 180 plus 60. And then if this was a test, I would do a really quick check before I moved on, because it takes 1 second. I would go cos 120, yay! I would go cos of 240. Hey, I know I'm right. It's kind of nice. In terms of the work I'll be looking for you to get full marks, I usually make these worth 2 marks apiece. I give a half mark for seeing the circle cast rule. I give a half mark for the reference angle, a half mark for theta 1, and a half mark for theta 2. In other words, if you just write down an answer, there's no way you can get full marks. And also the reason is, later on I'll show you how to solve this using your graphing features. I won't accept that. I'll show you how to use that to check your answer. I'm a tech nerd. We'll use the technology, but we got to do it old school because most of you won't have. And by the way, Rosanna, this works also on your scientific one, right? Yeah. And that's why you won't have a graphing calculator after this year. Most you have a scientific calculator. Next page over. Which trig function did they give me here? I won't deal with cosecant. There is no cosecant button on my calculator. I don't have a cosecant rule in the cast rule. What does cosecant go with? What does cosecant go with? Okay, anytime they give you a reciprocal trig function, look up, look up, look up, look up, look up, watch. Unreciprocal it. How? Look up, look up, look up, watch. She knows it's coming. So if they give me a reciprocal, cosecant or secant, or cotangent, there is an easy way to get rid of it. And I'll show you how. What did you say cosecant went with? This is the same as sine theta of 1 over negative 1.3456. I reciprocaled both sides. Reciprocal of cosecant is sine. Reciprocal of negative 1.3456 is 1 over negative 1.3456. Now I've turned into something that I know. Which trig function, although they started out with cosecant, which trig function did they really give me? Sine. Let's do our cast rule over here. According to this question, was sine negative or positive? Was my answer negative or positive? Where is sine going to be negative? Right? 3 and 4? Now let's find the reference angle. The reference angle is going to be the inverse sine, not of negative. I used the negative already. Of 1 over 1.3456. Now, how do I type that? I'm going to have to use brackets. I'm going to have to go inverse sine of bracket 1 divided by 1.3456. And I get a reference angle of, and I get a reference angle. Of course, you're all trying this. 48? You have to get comfortable and good at this. I want you to be trying these on your calculators quickly. Also, it speeds it up on the test or the quiz because you practice this. What that means, Roy, my friend, is that this angle right here is 48 degrees, and this angle right here is 48 degrees because my calculator can give me the reference angle. Here's theta 1. How can I figure out how big theta 1 is? 180 plus 48 degrees, which is what? 228 degrees. Here's theta 2 is Yump. That one. How can I figure out how big that one is? 360 minus 48 degrees. So this reference angle, George, it's a pretty good system. It's a pretty good system. There is one slightly quicker way, but the slightly quicker way requires you to memorize 3 different tricks for 3 different trig functions. It's not quick enough for me to bother teaching you that because kids get the tricks mixed up. This is almost, I can't say this is as good as it gets, almost as good as it gets. Okay? There is one slightly quicker way. I taught it my first year teaching Math 12 9 years ago, and my kids all got confused, and I said, okay, I won't do it again. Use the reference angles. Tie it into something you already know. 360 minus 48 is 312. Now, if I wanted to check here, I would go like this. 1 divided by the sine of, what was my first angle? That was my reference angle. What was theta 1? Sorry? 228. That should be really close to negative 1.3456. Yeah. And I would go 1 divided by sine of, what was my second angle? 312. That should also be really close there. So Cole, easy way to check your answers. And the checking takes like a second. So it's pretty worth doing. Secant theta equals 2.063. Which trig function did they give me? Secant. I won't deal with it. What does secant go with? Okay, really, this is cosine of theta equals 1 over 2.063. It's the reciprocal. You okay with that? Then you'd write it down, wouldn't you? And now, hopefully, it's becoming somewhat routine. What am I going to do next? Sketch and cast rule. Absolutely. Brooke, although originally they gave me secant, which trig function did they really give me? Cos. And was my cosine answer positive or negative? So where is cosine positive, folks? All and cos. Now we find the reference angle. The reference angle is going to be the shift or inverse cos of 1 over 2.063. Excuse me. I have to use brackets. 1 over 2.063. And I get 61 degrees. Again, what that's saying is that this angle is 61 degrees and this angle is 61 degrees. Theta 1 equals, theta 2 equals. Theta 1 is that big. Oh, how big is theta 1? Just 61 degrees. Theta 2 is that big. How can I figure out theta 2? 360 minus 61, which is 299, I think. And we could check our answers as well. 1 divided by the cosine of 299, 1 divided by the cosine of 61, and hopefully it'll be, we're rounding off each time, but it should be really close to 2.063. Solve sine theta equals 1.3. Okay. Which trig function did they give me? Sine, is that a reciprocal? Nope, so I can jump right in. Sine, according to this question, positive or negative? Which means I'm where? Here and here. Let's find the reference angle. The reference angle is going to be the inverse sine of 1.3. What do you get? What? What do you get? No, 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 no. Oh. By the way, what this is saying is there are no angles on the planet that have a sine value of 1.3. Can't be done. We'll talk about why that is in just a second. But what I am saying is, you know what? Not everything has an answer. How can I check my answers? Well, I've showed you how to do it by hand, but there's another visual way. I can use a graphical approach. Consider the first example that we did, which was solve, next page, sine theta equals 0.5. I think that was the first example, wasn't it? Okay. Instead of solving this by hand, we could graph this. Now all of you want to have your graphing calculators out. Instead of solving this by hand, we could graph this. So get out your graphing calculator and go into your graph menu. Delete any graphs you have there. First thing we're going to change is our view window. So can you go Shift View Window? What did I want theta to be between? How many degrees and how many degrees? Well, that's going to be my x variable. So my x min is going to be 0, and my x max is going to be 360. And I usually pick as a scale every 30 degrees. That's kind of a nice number. So that came from the fact that instead of theta on my graphing calculator, I'm going to put an x where the theta is, because that's our variable. You okay with that? Y min, you can leave as is for now. Or you know what? Y min, let's go from -3 to +3. That's why I'm telling you out loud. So x min, you're going to go from 0 to 360. Brooke, just because here goes from 0 to 360. And y min, I went from -3 to +3. And then I just picked a scale on the x-axis of 30 degrees, because that goes into 360 quite nicely. On the y-axis, my scale's going up by 1s, because it's from -3 to +3. Once you have that, press exit to get back to here. Here is how you can solve these graphically. You can graph the left side as one equation. Y1, we're going to just type in sine x. Sine button. Don't hit this x. Where is your x variable button? Right below the alpha. Right? Enter. And my second one, I'm going to graph 0.5, the right-hand side, as a second equation. Y2 equals 0.5. Okay? Now, I also wrote here window. Here's how you write a window. You go x min, which was 0, use square brackets, comma. What was our x maximum? 360, comma. What was our scale on the x-axis? 30. Then you do y min, -3, y max, 3, and 1. To show graph windows to the marker, to me, you use square brackets, you do your x min, max, scale, and then next to it or underneath it, you do your y min, max, and scale. Hit draw. Okay? Which of those do you think is the sine graph? Okay. The sine graph is the curvy one. We'll learn how to graph that. In fact, this right here, look up, look up. This right here, look up, is a line 0.5 high. That's that Y2. Where do you think the answers are? Where these two graphs, what? Touch. There's a fancy word for that. Can you press G solve? Can you press G solve? What's the fancy word for cross or touch? Intersect. Not intercept, intersect. Which is F what?
5.
If you press F5, there's the x equals 30 degrees. And then if you go arrow sideways, there's your x equals 150. So you can check your solution graphically if you wish. Not x-intercept, no. Look up. Not intercept, intersection, F5, right? There's, no. And this not there is no x-intercept or y-intercept. You're using the wrong words for the wrong stuff. So no, just arrow sideways, that gets it.
Okay.
No shortcuts here. If we do a sketch, it looks like this. The sine graph, draw this please, looks like this. Y equals 0.5 looks like this. And I'm interested in this point and this point. This point is 30, 0.5. And this point is 150, 0.5. Okay. And I think, is this the last one? No, nearly there. Oh, no, I got a few more graphs to do. Cool. Solve by hand and then check your solution graphically. You ready? Let's solve this by hand. They want us to find cosine of theta, the angle. Sketch. Cast rule. What quadrants are we in? Cosine, negative or positive, according to this question. So where's cos negative? Here and here, because it's positive in the other ones. Find the reference angle. That's going to be, oh, I got to get out of this menu and back to this menu. Shift cos of positive 0.891. 27 degrees. That means that on your own, find theta 1 and theta 2. I'll freeze the screen. Let's see if we get to the same thing. You get 153 and 207? Okay. How can we check our answer? We can check our answer graphically. The first graph, y1, we would graph cosine of x. The second graph, y2, we would graph negative 0.891. I would use the same view window. I would go from from 0 to positive 360. So I would go 0, 360 up by 30 degrees. And then my y's, I would go from negative 3, 3 up by 1. Cos x negative 0.891. Graph, oh, crosses right there, barely, and right there, barely. G solve intersection, and I get 152.999. I think that's 153. And I get 207.00008. Okay, that's 207 degrees. By the way, I made these work out nicely, evenly. Not all of them will. Sometimes they will just be decimals. Okay? Tough to make these work out evenly. If we were to do the sketch, we would go, okay. Cosine looks like that. The second line looks like that. There's my two solutions. (153, negative 0.891) and 207, negative 0.891. So there's a couple of ways to visualize this. Not only are you finding an angle, Jordan, what you're actually doing is you're finding where two graphs cross, which is in some ways a little more impressive. Do me a favor, go to your graph menu, go to the view window, so go Shift F3, and instead of going from -3 to +3 with your y's, how about instead go from -1.5 to +1.5. Do that. Change your view window. Shift F3. Leave the x's as is, but change your y min and your y max from -1.5 to +1.5. Nah, scale's fine. Once you've done that, hit exit. Delete these two equations. And just graph sine x. What does the sine graph look like? In fact, what letter does the sine graph look like on its side? What letter does the sine graph look like on its side? It would be wonderful if I could come up with some silly, easy way to help me remember what the sine graph looks like. I got nothing. You guys are on your own, I think. You have to come up with something. Okay? Here's what I want you to notice. How high is that right there? 1. How low is that right there? -1. Remember we tried solving sine x equals 1.3? If I graph 1.3 as my second graph, can you see why that had no solution? Remember the one that we had no solution? What? What we were actually saying, the reason there's no solution is, these graphs never intersect each other. There's no way that we can find values that work in both. That's another interpretation of no solution. What you're saying is if you graph the left side, graph the right side, they don't touch. So what does the sine graph look like? Like this. Hey, I can be more, write that down. I can be even more specific. What was our x max right here? What was our x max? Our x max. This is right here, 360 degrees. So, hey, what's that right there?
180.
The x-intercept is at 180 degrees. Hey, what's that right there at the top? How many degrees? 90 degrees. What's that right there when it's at the bottom? those four corners of the circle actually help me get the shape. The sine graph looks like an S. It starts at 0. At 90, it's at 1. At 180, it's back to 0. At 270, -1. At 360, it's back to 0. What does the cosine graph look like? Hey, go to your graphing calculator, delete your sine graph, and replace it with cosine. What does the cosine graph look like? If you turn your head sideways, what letter, sort of, does the cosine graph look like, sort of? If you turn your head sideways, what letter does the cosine graph sort of look like? You know what? I got nothing. So the cosine graph starts here. Looks like that. Hey, what angle do you think is right there? When is it at the bottom? How many degrees? 180. When is it at the top? At 0 degrees and at 360 degrees. When is it 0 high? 90 degrees. And you're eventually going to memorize these two graphs. I'm showing you right now an easy way that you actually don't technically need to memorize them. You can sort of derive it cleverly with a little bit of memorization. I'll be flogging this way more a couple lessons from now. Can you tell me why this next one has, why does that have no solution? What's the lowest my cosine graph gets? Not 1, lowest. -1. Will it ever get down as far as -2.3? Will those graphs ever cross? No. In fact, for sine and for cosine, it's going to be between -1 and +1. Turn the page. Last one. I come from a large family, not my personal family. I have one brother and two brothers, one older brother, one younger brother. My mom and dad both have lots of siblings. My mom in particular comes from a family of 9, and we're big on family gatherings. And we all get together, and we all like each other. But I don't know about you guys, if any of you have big families, there's always one ugly cousin. Okay, for me it's Cousin Marvin. Love Marvin to death. When I was younger, I thought Marvin was really cool because he wore a leather jacket, had long hair, and showed up on his Harley. Only periodically, and I wondered, why didn't Marvin show up at every family gathering? Now I know, because he was in jail, right? He's in and out of jail. He's the ugly cousin of my extended family. Tangent is the ugly cousin of the trig family. Sine and cosine are smooth curves. They look kind of similar. What does the tangent graph look like? Can you go exit? Can you delete cosine? And can you type tan x? And then hit draw. Does tangent look at all like sine and cosine? Is it lovely? Is it smooth? Is it nice? Okay.
It looks like the window is startup screen.
There's my cousin. I love tangent to death. Don't get me wrong. I love my cousin Marvin. And full disclosure, in the last 10 years, he has totally straightened himself out and is a great role model. But, you know, when I was like 8 years old, this guy riding in on his Harley seemed really, really cool. When I was 25 years old, you know, leaving his family, you know, not so cool, right? He's put himself back together, though, wonderfully. Hey, look at this. What does that look like? Well, it really looks like this. Sorry, that's a terrible drawing. There's other chunks as well. We're not going to be graphing tangent very much. Homework. Solve the following by hand. 20 questions. You got 20 minutes. You can get each one of these done in about 60 seconds or so. You have to do these on a separate piece of paper. For each answer, I'm going to be looking for sketch, reference angle, theta 1, theta 2. And then very quickly, you can check your answer on your calculator.
Let's do it, Sean.
For each question, assume we're between 0 and 360, so you don't have to go further. And I'm going to say, folks, I did not try and make these work out evenly. Give your answers to 2 decimal places if necessary. Okay? Answers next class.